This is RD Sharma Solution Class 12th. We are taking chapter probability. The exercise is 6th exercise. A bag A contains 5 white and 6 black balls. Another bag B contains 4 white and 3 black balls. A ball is transferred from bag A to bag B, and then ball is taken out of the second bag. Find the probability of this ball being a black. Now the questions coming up are based on the law of probability. So this law of probability, I introduced it just now. So let's try solving this question and then that will be introduced. Now this is your first bag. In this first bag, let us call it as A. We have 5 white and 6 black balls. Then we have another bag which has 4 white and 3 black balls. We are calling it as bag B. In all, total 11 in A and 7 in B. These are the total ones and we are going to utilize it just now. So the ball is transferred from bag A to bag B, and a ball is being picked up or drawn from bag B. Please remember, the ball is not picked up from A. From A it is transferred to B and then it is picked up. So now the first thing is that the picking up of the ball from A to B and transferring it to B, either white can go or a black can go. So this is the first point of contention. So we'll make the event like this. So the first event E1, as I told you that a white ball can be transferred from A to B or a black ball can be transferred from A to B. So a white ball being transferred from bag A to B is our E1. We're calling it as event. There is one more event in case it's not white. So it has to be a black ball. So a black ball is being transferred from bag A to bag B. This will be our second event. Now let's call the finding the probability of getting a ball black. So let's call this A event as getting a black from the second bag, or getting a black from bag, because it's obvious that we are picking one ball only from bag black, which is the bag B in this case. The second bag, a black ball is drawn. Now what is the probability is now? What is the probability of picking up E1? So how many balls are there in bag A? In all is 11. How many whites are there? 5. Because E is saying white ball is being transferred from A to B. Now coming to the probability of event 2. What is the total number of balls? 11. A black ball is being transferred to bag B. So 6 black balls are there. So 6 is the favorable cases, 11 are the total number of cases. 6 by 11 in this case. So now the probability of A is an event. Now probability of A, there are two things. We know that a white ball is transferred from A to B. Now what is the probability of getting a black from bag B is PA by E1, and first is the white ball being transferred and second is the black ball being transferred. So after doing these two, that is which comes in the denominator, it's not a denominator, it's actually a representation only. Then what is the probability of getting a black ball from the second bag? So when we transfer a white ball to the second bag, in all there are 5 balls now and 3 black balls remains. So in total we have 8 balls. So 3 is the favorable cases because only 3 black balls are there, and 8 are now the total number of balls. Now coming to the second part, if black balls is being transferred, now 3 black balls in the second bag becomes 4. So now we have 4 white balls in the second bag, and once this black ball is being transferred to the bag B, it's 8. It's 8 in total with a 4 black. So 4 divided by 8 is your probability, 1 by 2. Now law of probability says, so I am introducing law of probability here. So the probability of A is equal to probability of E1, that is the first event, multiplied by probability of actual event which we want when it is known that the E1 has already happened, plus the probability of event 2 multiplied by probability of the event we want when it is known that the E2 event has already happened. Now we are short of space, but I'll still write all these. Now there's one thing which is illogical. There has nothing to do with mathematics. Just for you to remember, when we write P1 multiplied by PA by E1, don't use your mind. E1 gets cancelled. It's not math, right? It's just for your recalling or remembrance. it will come as PA. It's not wrong. It's wrong. I'm not actually teaching you mathematics here. It's not mathematics. Just for you to remember, just assume that if even gets cancelled, you get a PA. So basically, probability of A when white ball comes plus probability of A when black balls come, you add them and you get a probability of A. Alright. Now probability of E1 has already been computed, which is 5 by 11 in this case. PA by E1 is 3 by 8. PE2 is 6 by 11. And PA by E2 is 1 by 2. So when we compute this, it's going to come as 39 by 88. So mostly the questions are like this only, which are coming up. So kindly give or pay attention to the solution here, which is the reference. We need to do like this along with the discussion we had just now. A purse contains 2 silver and 4 copper coins. So let's make again a box. Diagram is equal to 1000 to 10,000 words. So always remember, when you make the diagram, it makes your mathematics easier. Now we have the first purse, which has 2 silver and 2 copper coins. So in all, there are 6 coins in the first purse. The second purse has 4 silver and 3 copper coins. In all, there are 7 coins. Now just have an eye on 6 and 7 because we are going to use it just now. If a coin is pulled at random from one of the 2 purses, so one coin from any of the purses. So this coin is pulled at random from one of the 2 purses. So it can come from this one or that one. What is the probability that it is a silver coin? Let's call this as 1, this as 2. That all means that you have 2 ways. So first we have to select the way, then we will find out any restaurant or say the gas station. So first we have to choose the purse, because first the choosing of purse, then pulling out one coin, and then it comes to a silver coin. That is how the process should go. So let's call an event E1 that we are selecting first purse, or purse number 1. This is your event 1, and there is another event which is corresponding to this one only, selecting the purse number 2. So selecting purse 2 is our another event, E2. So what is the probability? We are taking an event here. We have to actually find out PA, probability of A, but we are calling PA is the probability. We are calling A as drawing a silver coin. So this is just a silver coin getting from any of the purse being chosen. That is an event A. So what is the probability of event E1? Since there are equal likely chances of choosing one from the 2 purses, it's half and half. So probability of E1 and E2 will be half. For example, when you toss a coin, it can be head and or tail. So a probability of getting head and tail are both half and half. 1 by 2 and 1 by 2. Same thing we are doing it here. Now what is the probability of getting a silver coin? Now probability of getting a silver coin, known that we have chosen first purse. Probability of choosing a silver coin when it is true or known that we have chosen the second purse. Now first purse, in all are 6. How many silver coins are there? 2. So 2 divided by 6 is the probability of getting a silver coin when it is known that we have selected first purse. Similarly here also, we are choosing the second purse. What is the probability of getting a silver? 4 are silver, 7 coins are there. So 4 divided by 7, favorable cases divided by total number of cases, 4 divided by 7. Now we'll apply the law of probability. This law of probability, it goes like this. I told you A is an event drawing a silver coin. So what is the probability of drawing a silver coin? It's PA. So this is probability of E1 multiplied by PA by E1. That is, what is the probability of getting a silver coin from the first purse, known that the first purse has been chosen? What is the probability of choosing the silver coin from the second purse, known that the second purse is being chosen? So we add these two. Now put the values. P1 is half, P2 is also half. Let's write that first. PA by E1 is 1 by 3, 2 by 6 is 1 by 3, 4 by 7 remains like that, and when we multiply this, you're going to get 19 by 42. That's your final answer. Now this is how you're going to go about it, write it, and this writing is very important because you can have good mind, but writing and telling is an art. Now one bag contains 4 yellow and 5 red balls. Bag has 6 yellow and 3 red balls. So we'll do it again. Please remember, there are questions coming which are exactly like this. I'm going to skip it and I'm going to do this once again for your recalling. Exactly similar question we have done. So we have 2 bags, First bag has 4 yellow and 5 red balls. Second bag has 6 yellow and 3 red balls. Now a ball is transferred from first bag to the second bag. So let's call the first bag as 1, second bag as 2. In all there are 9 balls in the first bag. In all there are 9 balls in the second bag as well. So we are transferring a ball from the first bag to the second bag. Now a ball is drawn from the second bag. We have to find the probability that the ball being drawn from the second box is yellow. So if you have any problem understanding the first question, this is the third question exactly similar to the first question we have done. So let's make an event E1 that the first bag is chosen, or this is a red ball is transferred. I'm still in the previous question, sorry for that. Red ball is transferred from bag 1 to bag 2. The another event will be a yellow ball is transferred from bag 1 to bag 2. So the first event is we have transferred a red ball to the second bag. Second event is we have transferred a yellow ball to the second bag. After this is done, we need to find out, or we have to have an event, which event is the actual answer to the question. Probability that a ball drawn is yellow. So a yellow ball is being drawn. This is your A. We have called it as A. Now coming to the probability of E1, probability of E2. What is the probability of first event? Red ball is transferred, that means, so in all there are how many balls? 9. In both the bags, how many balls are there? 9. Now when you transfer a red ball, what does it mean? There are 5 possibilities. 5 red balls are there. What is the probability of yellow being transferred? There are 4 yellow balls. So 4 divided by 9. Now probability of getting a yellow ball or drawing a yellow ball from the second bag is PA by E1. That means knowing that red ball is being transferred, what is the probability of getting a yellow ball from the second one? Or the probability of A by E2 is probability of getting a yellow ball if it is known that a yellow ball is being transferred from 1 to 2. Now when you transfer a red ball to the second bag, in all there were 6 yellow balls in the second one. 6 and 3 are initial. When you transfer a red ball, a 1 gets added to the second bag. So in all how many balls are there? 10. So these are yellow and red. So in all there are 10 balls. Now what is the probability of getting a 6 yellow? So 6 by 10. Now coming to this case 2. Now we are transferring a yellow ball. So 6 plus 1, now it becomes 7 yellow and 3 red remains like that. In all there are 10 balls now. And what is the probability of getting a yellow ball? Which is 7 balls here. So 7 by 10. So law of probability says, this says probability of A we are finding, and we'll apply the law of probability. So it will be PE1 multiplied by PA by E1, that you already know. So PE1 multiplied by PA by E1. A by E1 is that the probability of getting a yellow when it is known that a red ball is being transferred. And probability of yellow first, that is PE2, that is yellow ball is transferred from 1 to 2. And probability of when it is known a yellow ball is transferred from 1 to 2, what is the probability of getting a yellow ball from the second bag? So these all probabilities are already known to us. We have computed it. So let's write it. 5 by 9 PE1, PE2 is 4 by 9. PA by E1 we have computed 6 by 10. You can also write it as 3 by 5 if you want. 7 by 10 remains like this. When you multiply this, the final result will be 29 divided by 45. That's your final answer. So this is a repeat question which we have just completed. The first question was exactly like this. If you have any problem, then you can refer to it, and law of probability is now known to you. Now again, the same question, first, third, now it's being repeated, and this question is very important as far as your examination are concerned. So I've shown you the reference. You can follow this in order to solve it by yourself. So I hope that this is clear to you. Let's get to the another question now. The content of 3 bags 1, 2 and 3 are as follows. So let's make 3 bags here. 1 bag, 2 bag and 3 bag. I haven't read the question, but I know that if I draw like this, it will be easier to understand the question. The first one has 1 white, 2 black and 3 red balls. The second one has 2 white, 1 black and 1 red ball. So let's call them as bag 1, bag 2, bag 3. Then the second bag was 2 white, 1 black and 1 red ball. The third one has 4 white, 5 black and 3 red balls. A bag is chosen at random and 2 balls are being drawn. So any bag can be chosen. 2 balls are drawn. One has to be white and one has to be red. So the probability of getting a white and red ball is to be computed. So 1 white, 1 red, and first you have to choose one of the bag and then you have to draw the balls, and that needs to be white and red. So let's make 3 events. First event will be selecting the first bag. Let's call it as selecting bag 1. E2 will call it as selecting bag 2. This is going to be, we are selecting bag number 2. E3 is selecting the bag number 3. So since we have 3 bags and 1 bag can be chosen, 1 by 3 will be the probability of all of these 3. So probability of E1 will be the 3 bags are there. So in all, total 3 are favorable cases divided by total number of cases. Total number of cases are 3. So write 3 in the denominator for all of these. And since the probability of getting 1 or choosing 1 is 1, so 1, 1, 1. It's actually 1C1 in to be very precise. Because this C or permutation combination we can apply it here also. So probability of A, actually A is the event of choosing white and red. Choosing a white and a red ball is event A. Now probability will compute. I have written PA, which is wrong actually. So let me just strike this off. We are computing the probability later on. It's just an event first of all. Now probability of A, that is getting the white and red, if it is known that the first bag is being chosen. Now you see here. Now just concentrate on bag 1. We have come to the bag 1. You have chosen already the bag 1. Now you need to get a white and red from the bag 1. What is the probability? There are 2 ways in which we can compute the probability. Whichever you choose, it's up to you. I'll give you a hint for the first one. White and red. White probability is 1 by 6 and red is 3 by 6. So 1 by 6 into 3 by 6 is what? It's 1 by 12, right? But a white can be chosen first and the red can be chosen first. But a red can be chosen first and a white can be chosen first. So there are 2 probabilities you are going to compute and add them up. That is the probability of getting a 1 from the bag 1. A white ball is 1 only. In all there are 6. So 1 by 6. The second ball is what? It is red. So 3 by 6. But once you have taken out a ball, only 1 is remaining. Means 1 ball is curtailed. So you only have 5 balls. And getting a red ball from this is 3 by 5. So this comes as 1 by 10. Now you have to add it with the probability of first getting a red ball and then getting a white ball, because once you take a ball, the number of balls, it actually decreases in the bag. So red, white and white, red, just add them, you will get the probability. Now this we have already done in the previous exercise, so you know very well how to compute it. If you want to compute it, you can compute it like this. But the better way is choose the selection process. So white and red. There are 6 in all. So the denominator becomes, you are taking 2 balls. So 6C2. Now 1 is white, you are choosing 1 from the white. So 1C1 will be there. There are 3 red and you're choosing 1 out of it. So 3C1 will come. So 1C1 multiplied by 3C1 divided by 6C2. I hope you got the idea. If you didn't get the idea, we'll do it for the second and third. You will realize that. You please remember NCR. What is NCR? It's factorial n factorial r divided by factorial n minus r. What is 3C1? What is 1C? 1C1 is actually 1 only. 3C1 will be factorial 3 divided by factorial 3 into factorial. This is factorial 2. So 3 into factorial 2 divided by factorial 2, 3 will come. And 6C2 is factorial 6, factorial 2, factorial 6 minus 2. 6 remains, 6 minus 2 is 4, so 6 into 5, factorial 4 gets cancelled, 2 is 2 there, so 2, 3 is 6, 3, 5 is 15. So this comes as 3 by 15. Now when you compute like this, RW and RWR, see, one of this kind I already showed you, 1 by 10. You have to add with the other option and you will get same 3 by 15. It's up to you which process you would like to adopt. Now probability of getting a white and red ball, know that we have chosen the second bag. What is that? Again we'll use the combination process. How many balls are there? 4. So we are choosing 2 from it. White and red are 2. White are 2. So we are choosing 1 out of it. There is 1 red. So we are taking 1 out of it. So 1C1. So when you compute this is going to come as 2 by 6, which is 1 by 3. I hope you'll be able to do it. You already know this NCR. Now probability of choosing a white and red ball, known that we have chosen now the third bag. So this is PA by E3. Now how many balls are there? 12. Now choosing 2 out of it. Now how many whites are there? 4. Choosing 1. How many reds are there? 3. Choosing 1. So when you compute this is going to be 12 by 66. Now the required probability is what? Now applying the law of probability of event A, which is choosing a white and red ball, will be equal to probability of event 1, which is first selecting the bag 1, probability of E2 selecting second bag, and probability E, that is selecting the third bag. So when we choose the first bag, what is the probability of getting a white and red? Which is 3 by 15, which is PA by E1. Now when we have chosen the second bag, what is the probability of getting a white and red ball? It's 2 by 6, which is going to come just now. Probability of choosing the third bag, and along with that, when it is known what is the probability of getting white and red from the third bag. So all these probabilities are already been computed. Let's put this value. P1, P2, P3 are 1 by 3 as earlier discussed. PA by E1 we have just computed it as 3 by 15. A by E2 we have computed 2 by 6. And third one is 12 by 66. When you compute all of these, the final result will be 118 by 495. So 118 divided by 495 is the probability of this question. So this way, whichever way you want, this is the final answer. So this is how you are going to write it, and this reference is very important because this kind of questions are going to come in the later part also. I hope. An unbiased coin is tossed. If the result is head, a pair of unbiased dice is rolled and the sum of the numbers obtained is noted. If the result is a tail, a card from a well shuffled pack of 11 cards numbered 2 to 12 is picked and the number on the card is noted. What is the probability that the noted number is either 7 or an 8? Now it's a different kind of question, a good question. So first of all, we have a coin, and this coin leads to two decisions. So this coin can produce a head or can produce a tail. Now if head comes, then two die, that is a pair of unbiased dice, that means two dice we are talking about. So these dice are rolled. This is only happening when head is coming, or head is the outcome of the coin. So the addition of the number which appears on these dice are or has to be 7 or 8. So it can be a 7, it can be an 8. Now if the outcome is a tail, when you toss a coin, if tail comes, a card is taken from 2 to 12. That is, there are 11 cards. Number 2 to 12. These are not that deck of cards which we talked about. This is just some random cards from 2 to 12 numbers. So the number which appears in this card should be either 7 or an 8. So both the cases, if head comes, the dice, two dice are rolled and the number should come as 7 or 8, the addition of these two numbers. Tail, the number which is picked up from the card should be 7 or 8. So we make two events C1 and E2. So the coin can produce head or can give us a tail. So the coin shows head is E1, then coin shows tail, that comes to the tail. This is the second case. Now let's compute the probability here. See, probability is half and half. Probability of getting a head and tail are equal. So when you have 1 as the final probability, 1 by 2 is the equal probability. Now what do we want to have? We're calling A as whatever is the result of this question, or the question is asking about something, we call it as A. So number which appeared or number noted is either 7 or 8. So it can be the sum of the number on the two die or the number which is picked up from the card. Now probability of getting a 7 or 8 if the coin shows head. And the second probability will be the probability of getting 7 or 8 if tail appears. So PA by E1 is when head appears, what is we are going to get on the dice, and when the tail appears, what are we going to get in the cards. So what is the probability of getting a 7 or an 8? So for 7 we can have 1 6, 6 1, 4 3, 3 4, 2 5, 5 2. So I'm writing the 8 number first. 4 4, 2 6, 6 2, 6 4, but it has to be 6 2. There is a slight mistake here. Please correct it. 5 3, 3 5, and as I mentioned earlier, so 2 5 and 5 2 also. So in all there are 11. Number of elements in this set of getting a 7 or an 8 as an addition of two dice being tossed is this one. So when you toss a coin, the total number of cases are 36, 6 into 6. A number of favorable cases are this 11 by 36. Coming to the second part. So the card can produce 7 or 8. So there are two possibilities only. And in all there are 11 cards. It's given in the question. So 2 by 11 is the probability of getting 7 or 8 when a card is randomly picked from 2 to 12. So now applying the law of probability. So probability of A, what is that probability of A? It's probability of E1 multiplied by probability of A by E1. You know why we are doing it by now. PE2 multiplied by PA by E2. It's not divided, right? A divided by A2 it is not like that. It is just that if we are aware of E2, what is the probability of A? That is, if we are aware of, say, head, what is the probability of getting 7 or 8? Or what is, if we know that it is tail, what is the probability of getting 7 and 8? So let's put the probabilities which we have already computed. PE1 and PE2 are already half, which we discussed earlier. PA by E1 has been computed as 11 by 36 and PA by E2 is being computed as 2 by 11. So this whole comes out to be 193 divided by 792. This is your answer. Now this is how this will be done. This is how you are going to write it. It's a good question and you must do it twice or thrice. A factory has two machines, A and B. Past records show that the machine A produced 60% of the items of output and machine B produces 40% of the items. Now A produces 60. So if 100 we are talking, 60 comes from A, machine A, and 40 comes from the machine B. Further, 2% of the item produced by machine A were defective and 1% produced by machine B were defective. So 1% out of this 100, or 1 out of this 100 are defective. Sorry, 2 for A it is 2 and for B it's 1%. So if an item is drawn at random, what is the probability that it is defective? So we have to find out the probability of the item being defective. So A is what is expected, that is item being drawn is defective. This is the question and this is the A which we would like to answer, probability of A. PA is what is sought. E1 we are selecting as, or we are taking as, machine A is being selected. So this is E1 and E2 is machine B is being selected. So machine B is selected comes out to be E2. Now we'll apply the law of probability. That's why we need this E1 and E2. So this is A, machine A. This is machine B. 60% of the output is coming from A. So what does it mean? A gives 60%, B gives 40%. So 60 by 100 you can write, and B, for that B can give us 40 by 100 as mentioned in the question also. 2% of the item produced by machine A are defective. So if we have chosen an item which happens to be coming from machine A, 2 out of 100 items are defective. Now when we choose an item from B, the item chances of being defective is 1 by 100. So probability of item being defective if machine A is selected. So this is already given in the question. It's simply 2 by 100. 2 by 100 we can write. The probability of when we choose machine 2 and the items are defective, item is defective, is 1 by 100 which is given here. There is A DF written. We just corrected it to BE def. So 1 by 100 it is. Now let's apply the law of probability. Now how does this work? Probability of A, PA, is PE1 multiplied by PA by E1 and PE2 multiplied by PA by E2. So PE1 has to be multiplied by what? A by E1. This is E1. And PE2 multiplied by PA by E2. So A by E1, A by E2. With E1 it is A by E1. With E2 it is A by E2. Now this 60 by 100 is what? Probability of machine is selected, A is selected. It's already given in the question, 60 by 100. And probability of E2 is what? It's 40 by 100. That is probability that the machine B is selected, which is 40% of the time. The 40% product is coming from B. 60% product is coming from A. So let's put these values 60 by 100. PE2 is 40 by 100. PA by E1 is 2 by 100 and PA by E2 is 1 by 100. So when we compute this, is 120 divided by 10000, 160. So it will be 0.016. So 0.016%. Why we are writing in percentage? Because question is all in percentages. This is your answer. So this is how you are going to write it whenever you happen to write it. All right. Now this question, and there is another question which is coming up, and I'm just skipping it for a while. Why? Because there are 3 or 4 questions like this coming up. So rather than explaining all of this exact same question we have already completed in the question 1 to 4. 2 questions were there, 1 and 3, and 2 or 3 more questions are coming up. So what we'll do is, I'll just show you the reference here. If you have any problem, you can refer. This also the same question we are talking about, exactly similar question. And this also, I'm going to show you the reference. And the last question of this type, exactly this type, we are going to solve it. Actually, we have done it already. But in order to complete this exercise, we will do the final question, which is on this theme, on this exact. An urn contains 10 white and 3 black balls. Another urn contains 3 white and 5 black balls. 2 are drawn from first urn and put into the second urn, and then a ball is drawn from the latter. Find the probability that it is a white ball. Now this question is somewhat different. Well, it follows the same logic, but there are 2 boxes. There are most of the questions which we have done and which are we going to do also. The next question, those have one ball being transferred from one bag to another. So we have 10 white and 3 black in the first bag, 3 white and 5 black in the second bag. 2 balls are being drawn from the first bag and they are placed in the second bag, and now 1 ball is drawn from the second bag. So now the second ball, which second bag, which contains 3 white and 5 black, when it is added with the 2 balls from the first bag, we have to find out the probability that this ball which comes out from the second bag is a white ball, right? So what are the possibilities? Both white can be picked up from the bag 1, both black can be picked up from the first bag, or a white and a black ball can be picked up. So these are all mutually exclusive events, but the result of white coming out from the second bag totally depends on what is being chosen from the first bag to be placed at the second bag. So we'll make events like this: E1, E2, E3. Now I told you there are 3 possibilities. The first possibility is that 2 red ball, there is no red ball. 2 black balls are taken or picked up from the first bag. So it's a separate event. Means you are picking up, of course you are placing it in the second bag. But the event is to pick 2 black balls from the first bag. And then we have the second event where we assume that 2 white balls are being picked up from bag 1. You can also add that it is transferred from first to the second bag. This also can be added. But the main idea is that 2 black balls is chosen, 2 white ball is chosen, and then 1 white and 1 black ball is chosen from bag 1, which we are calling as E3. E3 is what? The event 3. Now what is the probability? Let's find out the probability here itself. The probability of picking up 2 black balls from bag 1. First of all, for all these probabilities, we are concentrating on the first bag. How many balls are there in all? 10 plus 3. So favorable cases divided by total number of cases. So all these E1, E2, E3, because we are talking about the first bag, 13 will come in the denominator, which is the total number of cases, and we are picking up 2 balls. So 2 balls picking up is 13C2. Similarly, for probability of E2 and probability of E3, the denominator shall contain 13C2. That is, we are picking 2 balls out of 13 balls, which counts to be 13C2. Alright. Now, next thing comes with the favorable cases. So there are 3 balls, 3 black balls, we are picking 2, 3C2. There are 10 white balls, we are picking 2 white balls, so 10C2. This is 10C2. 1 white and 1 black, so there are 10 whites and 3 blacks. 1 has to be picked up, each of them. So it will be 10C1 multiplied by 3C1. So this NCR, you know, it is factorial n divided by factorial r divided by factorial n minus r. So this computation, I leave it to you. I hope you'll be able to do. I'll just write the answer because the logic is very important, which I am trying to explain here. So this will come as 3 by 78. Probability of E2 will be 45 by 78. The third probability will be 30 by 78. So there are 3 cases. The thing which I discussed earlier, now we are implementing it. What is the probability of getting a white ball from the second bag if it is known that 2 black balls has been transferred from bag 1 to bag 2? So A probability, which is the probability we always take, that is to compute the questions probability, which is the probability of getting a white ball. So PA, probability of getting a white ball. Probability of getting a white ball if it is known that 2 balls are being transferred from first to second bag. Similarly, PA by E2, PA by E3. A by E3, that is 1 white and 1 ball is transferred. A by E2, 2 white balls are transferred, then what is the probability of getting a white ball? So PA by E1, still PA by E3. So we have to find out the probability when the E1, E2, E3 event has already happened. Either of them. So initially we had 3 and 5, that is 3 white and 5 black balls in bag 2. When you transfer 2 black balls, 2 will be added to 5 black balls because 5 black balls are there. When you transfer 2 white balls, so 3 plus 2 will come. When you transfer 1 white and 1 black, 3 will be added with 1 and 5 will be added with 1. So what is the total? See, 8 ball was there in the black bag 2. When you transfer 2, any color, devoid of any color, it will become 10 in all. So total number of cases will be 10 in the denominator for all of these after 2 balls are being transferred. Now what is the favorable cases of getting a white ball? How many white balls are there? 3. How many white balls in the second case? 3 plus 2 because 2 has been added. So 5. Now what is the probability here? Only 1 white ball is being added. So in all there are 4 white balls. So in order to pick 1 white ball, there are 4 possibilities. So 4C1, that is 4 will come. So it will be 4 divided by 10. Now we'll apply the law of probability here. So this is PA equals to PE1 multiplied by PA by E1. This will give you the first probability. Then we'll add the second probability PE2 multiplied by PA by E2. Third one will be PE3 multiplied by PA by E3. All of these probability we have already computed. So just take the value, put it in here. 3 by 78 here. PE2 was 45 by 78. PE3 was 30 by 78. PA by E1 is 3 by 10. PA by E2 is 5 by 10. And this one is 4 by 10. Now multiplication is done. Let's add. The final result is going to come as 59 divided by 130. So let me write it again. 59 divided by 130 will be the final result. So this is how you're going to go about it. So now this question is the only question which is different from the other questions, though it is following the same league. Now if you remember, I have skipped 2 or 3 questions earlier, and there were few questions of the exact same theme we have already completed. That's why I skipped it. But I told you that we will do it. We will not skip all those questions which are similar. So this is the question, and 4 to 5 questions in these 12 questions which we have done, we have already completed it. But we will do it in order for you to recall how to do this. So those who haven't understood the previous discussion, let's understand this. One bag has 6 red and 8 black balls. So in all there are 14 balls. The second bag, it has 8 red and 6 black balls. So this is 8R and 6 black, 6B. Now we are picking up a ball from first and transferring it to the second one. Now we are picking the single ball from the second one now. What is the probability that the ball picked up from the second bag is red in color? So we'll make the events like this: E1, E2 and A. A is always the answer. That is what is asked in the question. The question is asking about red in color. So a red ball is drawn, which is the A. What is E1? It is possible that you can pick a red ball from first bag and transfer it, or you can pick a black ball and transfer it. So even we can make it as, say, black ball has been transferred from bag 1 to bag 2, or you can just say black ball is being picked up from bag 1. This is also the same probability. E2 probability is red ball is picked up from the first bag, or red ball is transferred from first bag to the second. So we'll compute, or we'll find out the probability here itself. PE1, PE2. So in all, how many balls are there? 14. So 14C1 is 14 only, so it comes in the denominator. Now we are taking black balls, so 8 black balls are there. 8C1 is 8. We are taking 6 of them. We are picking 1, so 6C1, so 6 will be there. 8 by 14 and 6 by 14 will be the probability of black and red ball being picked up respectively. The second bag has 8 and 6 red and black ball respectively. Now we are transferring one ball. It can be a red, it can be a black ball. So the scenario will become like this. But before that, this is the probability which we are going to compute. When black ball is being transferred from 1 to 2, what is the probability of picking up a red ball? from the second bag. When a red ball is being transferred from 1 to 2, what is the probability of getting a red ball from the second bag? These are the two probabilities. In both the cases, because one ball is being transferred here, in all there were 14 balls, but now this is in all the bag has 14 balls, but one ball has been transferred, so in all there are 15 balls now. This 15 comes in the denominator. So if we transfer a black ball, now we have to pick up one red ball from 8 red and 7 black balls. So we don't have to worry about the black anyways. So 8 by 15 will be there. But when we transfer a red ball from 1 to 2, the red ball numbers will increase. That will become 9 red balls now. So you are picking up one from these 9 red balls. So the numerator will be 9. This is 9 by. So what does the law of probability says? When you apply the law of probability, this PA is equal to PE1 multiplied by PA by E1 plus PE2 multiplied by PA by E2. So what is PE1? 8 by 14. What is PE2? 6 by 14. What is PA by E1? It's 8 by 15. What is PA by E2? It's 9 by 15. Add them. When you add these, it will be 59 divided by 105. So this is how you're going to do it, because writing is very important. I have been saying it every time. Three machines E1, E2, E3 in a certain factory produce 50%, 25% and 25%. That is 1 by 2, 1 by 4 and 1 by 4 respectively of the total daily output of electric bulbs. So let's understand this diagrammatically. We have three machines here. These are three machines, E1, E2 and E3. So the production in E1 is 50%. That is, in all there are 100 product or 100 bulbs or 100 tube. 50 will be from E1, machine 1, 25 will be from machine 2 and 25 will be from machine number 3. It is known that 4% of the tubes produced on each of the machines E1 and E2 are defective, and that 5% of those produced in E3 are defective. So the E1 and E2 both have the defective percentage as 4%. I'm not saying both of them combined is 4%. I'm just saying E1 defective percentage is 4 by 100. E2 defective percentage is 4 by 100. The third one is 5 by 100. 4 by 100 becomes 1 by 25. 5 by 100 becomes 1 by 20. So if we pick any tube or bulb randomly, we have to calculate the probability that it is going to turn up as defective. The probability we have to compute, which is the tube is defective, which we call it as A. So you can change the word, like you can have a tube or a bulb. You can write anything here. So let's stick with tube now. A is tube is defective. So this E1, E2, E3. E1 event is, see, we don't have to write E1, E2, E3 because this is already given in the question, E1, E2, E3. But since we are going to apply the law of probability, for that we need E1, E2, E3. That is why we are writing it. So E1 is that product coming from E1, second one product coming from E2, third the product or tube or bulb coming from E3, because it is already given the question, 50%, 25%, 25% is that only. Now what is the probability? Probability is what just I said. Probability of E1, probability of E2, probability of E3. It's 50%, 25% and 25% respectively. What does it mean? It's 50 by 100. The probability of E2, 25 by 100. Third one, 25 by 100 again. This is half. These both are 1 by 4 and 1 by 4. So PE1, PE2, PE3 are 1 by 2, 1 by 4, 1 by 4 respectively. Let's come to the conditional probability. That is, what is the probability of the product being defective if it is coming from the first machine, that is E1. EA by E1, it is 4 by 100 given the question. PA by E2, that is probability of it being defective, it is coming from second machine, is again 4 by 100. The third one is if the product is defective and it is coming from machine number 3, it's already given the question, it is 5 by 100. This will be 1 by 25, 1 by 25 again, and this is 1 by 20. Now we are applying the law of probability. The probability of getting a defective product is PE1 multiplied by PEA by E1 plus PE2 multiplied by PA by E2 plus PE3 multiplied by PA by E3. So PE1, PE2, PE3 are 1 by 2, 1 by 4 and 1 by 4. I'm writing it like in order to represent it this way. This PA by E1 is 1 by 25, PA by E2 is 1 by 25 and PA by E3 is 1 by 20. Add them, result will be 17 divided by 400. This is the probability of getting a defective cube or a ball. So this is how this will be done. It was a good question. You can follow these steps. So this is all about this exercise. Thank you so much. Have a good one.